Welcome everyone. Today we are starting one of the most essential topics in chemistry, chemical formulas. Think of chemical formulas as the language chemists use to describe substances. Just like a recipe tells you what ingredients are in a dish, a chemical formula tells you which atoms are in a compound and how many of each. For example, the formula H2O tells us that water is made of two hydrogen atoms and one oxygen atom. This is very simple but incredibly powerful. Understanding this helps us figure out how substances react, how much of each substance is involved, and even what a molecule looks like. There are a few types of formulas, empirical formulas which give the simplest ratio of atoms, molecular formulas which shows the actual number of atoms in a molecule, and structural formulas which gives a visual of how atoms are connected. Here we are going to focus on molecular formulas which shows the actual number of atoms in the molecule, and you will learn how to write chemical formulas and how to name them. Let's look at how we actually write formulas for two main types of compounds, ionic compounds and covalent compounds. Ionic compounds are made of metals and nonmetals. The metal loses electrons and becomes a positive ion, while the nonmetal gains electron and becomes a negative ion. You can see there are some examples given for ionic compounds like sodium chloride NaCl, the formula, magnesium oxide MgO, potassium iodide Ki. When writing their formulas, first write the symbols of the ions involved, balance the charges so that the total positive charge equals to the total negative charge, and then use subscripts to show how many of each ions are needed. Covalent compounds are made of nonmetals. These atoms share electrons instead of transferring them. Some examples are carbon dioxide, nitrogen monoxide, sulfur dioxide. When writing covalent formulas, use prefixes in the name to determine the number of each atom. The first element keeps its name, the second uses a modified name ending in ite. Then convert the prefixes to subscripts. So remember, when you write formulas for ionic compounds, you write the metal symbol and nonmetal symbol and then balance the charges. For covalent compounds, since there are only nonmetals, we use prefixes. Writing formulas for ionic compound. Let's take an example, magnesium nitride. Magnesium is in group 2, it's a metal and it makes 2 plus charge. Nitrogen comes from group 5 and it makes 3 negative charge and it is a nonmetal, therefore we call it nitride after making 3 negative charge. Because compounds are electrically neutral, you can determine the formula of a compound this way. The charge on the cation becomes the subscript on the anion. The charge on the anion becomes the subscript on the cation. If these subscripts are not in the lowest whole number ratio, divide them by the greatest common factor to get the formula. Once you write the formula, we can check their charges, whether they are neutral in the formula. As you can see, if you take magnesium here, the subscript tells you how many magnesiums are there. There are 3 magnesiums. Usually magnesium is plus 2 since it is from group 2, and we can multiply this by the number of magnesium here, which gives you positive 6 total. When you take nitrogen, there are 2 nitrogen atoms in the formula because the subscript is 2. Nitrogen makes 3 negative charge, and when you multiply this by the number of atoms you have, that gives you negative 6. Now you can see in the formula you have Mg3N2. So totally this is positive 6 and this is negative 6. So these two will cancel out and the charge is 0 when you make this formula. When you are writing chemical formulas, ions are really important. When an atom loses electrons, it makes a positive charge. When an atom gains electrons, it makes a negative charge. We have already discussed about these cations and anions when we are discussing the periodic table. Let's look at them again. Group 1 removes 1 electron and they make +1 charge. Group 2, including magnesium, calcium, strontium and barium, makes 2 plus by removing 2 electrons. Group 3, aluminum removes 3 electrons and make aluminum 3 plus. So those are main group elements, and the transition metals, as you can see here, we have not mentioned any transition metals here. However, transition metals do not have fixed charges. As an example, if you take copper, this removes 1 electron and make copper +1, as well as this can remove 2 electrons and make copper +2. Another example, iron. Iron element can remove 2 electrons to make iron 2 plus, as well as by removing 3 electrons iron can make 3 plus. So this is different than the main group elements. When we think about the anions, look at the non-metal side, right side of the periodic table. Group 7 always gain 1 electron and make -1 charge. Group 6A gain 2 electrons and make 2 negative charges. And group 5 gain 3 electrons and make 3 negative charge. Let's look at more examples. Copper 2 chloride. Symbol for copper is Cu. Since it is given in the formula as copper 2, this makes 2 plus charge. Chloride, the symbol is Cl. This is coming from chlorine. So chlorine is in group 7. Therefore, chlorine makes -1 charge and it is known as chloride. To write the formula, we need to balance the charges here. So copper has 2 plus and chloride has -1. In order to balance the charges, if we write 1 copper and 2 chlorides, because copper +2 and there is 1 copper only, chloride -1. To balance the total positive charges here, you should have 2 negative charges. Therefore, you have to add 2 chloride ions. So it gives you 2 negative, which balance out and the total charge is 0. So formula for copper 2 chloride is CuCl2. Let's take another example, lead 4 oxide. Symbol for lead is Pb. In the name it says lead 4 oxide. So this 4 is its charge. So it's 4 plus. Oxide is the symbol is O, which is coming from oxygen. Since it is in group 6 of the periodic table, it gains electrons because it's a non-metal. And there are 2 electrons it's gaining, therefore 2 negative. When you are balancing out charges, there are 4 positive charges and 2 negative charges to balance out. If you write the formula as we described at the very beginning by taking the charges as your subscripts and switch them, so lead take 2 as its subscript and oxygen take 4 as its subscript. When you switch them like this, right? So now lead is plus 4 and there are 2 of them. So you take total positive 8, and oxygen negative 2. There are 4 of them, and which gives you negative 8. So charges balance out, and the total charge of the chemical formula is 0. So this is how you write the formula for lead 4 oxide. However, you can see these subscripts are not in the lowest whole number ratio. Therefore, we can divide them by the greatest common factor and achieve, by dividing 2, you can obtain PbO2 as the formula for lead 4 oxide. Polyatomic ions. Polyatomic ions are charged groups of atoms bonded together act as a single ion. They can be positive like ammonium, nitrogen containing polyatomic ion which has a positive 1 charge, or negative like sulfate SO4, sulfur containing polyatomic ion which has a 2 negative charge. You will often see them in ionic compounds paired with metals or other ions. Do not break these polyatomic ions apart when writing formulas. They stay as a unit. We use parentheses when more than one of the same polyatomic ion is needed to the formula. Memorizing common polyatomic ions make writing formulas much easier. You can see there is a table containing several polyatomic ions, and they have grouped with the non-metal like nitrogen containing polyatomic ions, carbon containing polyatomic ions, sulfur containing polyatomic ions, like that. Many names end with ate, ate, or ite, ite, depending on the oxygen content. If I take an example, nitrogen containing polyatomic ions, there are 2 with negative charges. The first one here, NO3 minus, and the second one NO2 minus. Both have negative 1 charge. However, the very first one, we call it nitrate. The second one is nitrite. So nitrate has 3 oxygens, nitrite has 2 oxygens. If I take another example to explain this, sulfur containing polyatomic ions, SO4 2 negative, the name is sulfate. SO3 2 negative is sulfite. Again, 4 oxygens is ending with ATE, 3 oxygens here in sulfite ending with ITE. It's not the amount of oxygen, but the less oxygen always name end with ITE. Higher number of oxygens in the same category ending with ATE. If you want to write chemical formulas correctly, you should study these polyatomic ions. Especially study the most common polyatomic ions like nitrate, chlorate, carbonate, sulfate, phosphate. Let's do few more examples to write formulas for ionic compounds which are containing polyatomic ions. The first example is sodium sulfate. In order to write the formula, let's write their ions. Sodium is Na, that's the symbol. Since sodium is in group 1A, it removes 1 electron and makes +1 charge. Sulfate is a polyatomic ion. To write this formula, you should know what is sulfate. So sulfate is SO4 and it has a charge which is 2 negative. So whole group here has a charge which is 2 negative. When you are writing this formula, you need to cancel out the charges or balance out the charges. So here you have +1 and -2. So when you are balancing out charges, if you have 2 sodium ions like Na plus and Na plus with 1 sulfate, 2 negative, 2 plus charges are here and 2 negative charges will cancel out. Therefore, you need 2 sodiums. We will use it as the subscript, and 1 sulfate. We do not usually mention 1 here. This is just 1 sulfate group. So this is the formula for sodium sulfate. Second example is iron 3 carbonate. Iron is Fe. Since it is a transition metal, it has given the charge in Roman numerals in the name. So this is iron 3 plus. Carbonate is a polyatomic ion. The formula is CO3. Whole group has 2 negative charge. In order to balance the charges, we can use the method we discussed at the very beginning. Here you have 3 plus in iron. So you can use this 3 plus as the subscript for the carbonate, and you can use your 2 negative charge which is coming from carbonate as the subscript for iron. So your formula is Fe2CO3, and there are 3 carbonates. So now we are going to use parentheses because there is more than one polyatomic ion in this formula. So you use parentheses and there are 3 carbonates. Let's check their charges. So iron is 3 plus. So there are 2 ions in the formula which gives you plus 6. This is for iron. And when you take for carbonate, carbonate group is 2 negative charge, and there are 3 carbonates in the formula which makes negative 6. Now these 2 will cancel out and you have a neutral compound, and this is the formula. Next example, calcium hydroxide. Calcium is in group 2, so calcium makes 2 plus. Hydroxide is another polyatomic ion, contains oxygen and hydrogen with a negative 1 charge. So you can see calcium gives you plus 2. In order to balance the charges, you should have 2 negative here. So you have just 1 negative. If you have 2 negative charges, it will cancel out. So you have to use 2 hydroxides in the formula. So calcium CaOH, and there are 2 hydroxides. This is the formula for calcium hydroxide. Writing formulas for covalent compounds. Covalent compounds contains only nonmetals and they share electrons but do not transfer electrons. We usually use prefixes in names to show how many atoms are there. When you are writing formulas, first identify the elements in the name and then use prefixes to get the number of atoms. Then write symbols with subscripts. Let's look at the first example here, carbon tetrachloride. So carbon is C, tetrachloride, that means there are 4 chlorides. Tetra tells you there are 4 chlorides, so CCl4. Dinitrogen tetroxide. The prefix here is di, tells you there are 2 nitrogens, so you write the symbol for nitrogen and use 2 as the subscript. Tetraoxide, tetra again, for 4 oxides, so N2O4. Carbon monoxide. Carbon, mono is the prefix for number 1, so there is only 1 oxide, CO is carbon monoxide. Diphosphorus pentoxide. So you have phosphorus, there are 2 phosphorus because it's di, so P2. Pentoxide, penta means 5, so P2O5. Nitrogen dioxide. Nitrogen is N. Dioxide means 2 oxides, so NO2. Phosphorus trichloride. Phosphorus symbol is P, and trichloride means there are 3 chlorines, so PCl3. Naming chemical compound. This is also another important topic in chemistry. Let's look at ionic compounds. When you have ionic compounds, we know ionic compounds containing a metal part and a non-metal part. When we are writing the name of these ionic compounds, first we write the metal name or cation name. If the cation has a fixed charge, you just write the name of the element. And if the cation have more than one possible charge like transition metals, write the charge as a Roman numeral in parentheses. Then you make a space and then you write the name of the nonmetal. If that anion part or the nonmetallic part is an element, change its name ending to IDE. If the anion is a polyatomic ion, simply write the polyatomic ion's name. Let's look at some examples. I will take easy examples like NaCl. So sodium has a fixed charge which is +1. So we do not need to mention that specifically because it's a fixed charge. So first we write the name of the cation which is sodium. And then we make a space here. Then the second part is the nonmetal. So chloride is the nonmetal. So the second part write as chloride. So the name of this compound is sodium chloride. If you have a transition metal which has more than one cation like this in this compound, we know that since we already talked about writing formulas, chloride is -1, and in this case this 3 coming from iron, therefore we know iron has 3 positive charge here and chlorine has for -1. Since iron has 2 different cations, here we have to mention the charge of the cation. So the name is iron. And we write the charge in the Roman numerals 3, iron 3, and the non-metal part is chloride. Let's see if you have a polyatomic ion in the formula. Like Cu, NO3, and there are 2 NO3s according to the formula. So this is copper. Again, copper is in transition metals and it can make 2 different charges, +1 and +2. Now you have to check what is the charge on copper. We know nitrate is always NO3 -1. So this 2 is coming from copper. So copper is 2+ in this case. So the name of this formula is copper 2 nitrate. When you have polyatomic ions in the formula, you simply write the polyatomic ion's name. Therefore, when you are writing names of ionic compounds, first check whether the metal has more than one cation. If so, you have to mention that cation in Roman numerals. But if the cation has no variable charges and it's a fixed charge, then you just write the element name and the nonmetal name. Let's look at how we write names for covalent compounds. Covalent compounds containing only nonmetals, the name of the element farther to the left in the periodic table or lower in the same group is usually written first. A prefix is used to denote the number of atoms of each element in the compound. You can see this table shows you prefixes used in naming binary compounds formed between nonmetals. Mono tells you there is only one group of that element. Usually, mono is not used on the first element listed. We usually use mono for the second part of the element. Then di is 2, tri, 3, like that you can see what are the prefixes we usually use. Let's look at some examples like CO2. So you have one carbon, the name is carbon. We do not use mono at the beginning. And there are two oxygens, so it's dioxide. And then another example, CO. Now there are only one carbon and one oxygen. For the first one we write carbon, do not use mono. But for the second one there is only one oxygen, so we use mono and it is monoxide. And another example, PCl5. So it is phosphorus and there are 5 chlorines, therefore pentachloride. Another example, N2O5. There are 2 nitrogens, so you write dinitrogen. And there are 5 oxygens, so usually this is pentaoxide. If the prefix ends with A or O and the name of the element begins with a vowel, the two successive vowels are often elided into one. Therefore, this becomes dinitrogen pentoxide. We drop the A. Next group is acids. When you are writing names of acids, there are some rules you need to follow. If the anion in the acid ends with IDE, change the end into IC and add the prefix hydro at the beginning of the name. As an example, if you have HCl formula here, we know this is chloride, right? Then since it is ending with IDE, we change this into IC, which is chloric. So the name of this HCl is, we use hydro at the beginning and the anion part is chloric, so hydrochloric acid. If the anion ends with ATE, change the end into IC. If you have HNO3 acid, so this is ATE, ending with AT here because it's nitrate. We know the polyatomic ion nitrate, so we write the name as nitric acid. If you have H2SO4, the polyatomic ion is sulfate here, which is ending with ATE, so the name is sulfuric acid. If the anion ends in ITE, then change the end into OUS and acid. If you have HNO2, we know this is nitrite. So if the name ending with ITE, we have to change it to OUS. So this is nitrous acid. And the next acid, H2SO3, same family like sulfuric. This is the polyatomic ion here is sulfite. So the name is sulfurous acid because it's ended with ITE and we change that into OUS. So you can see here the very first one we discuss HCl. In this group we can include HF, HBr, HI. So hydrofluoric acid, hydrobromic acid, hydroiodic acid and hydrochloric acid we already discussed. So they are not containing any oxygen. So you use hydro at the beginning. But however, the other two examples I discuss here, this one and this one, you can see they all contain oxygens. So something you can memorize: when you have oxygens in your acid, you do not use hydro prefix at the beginning. You just look at the polyatomic ion, and if the name ends with ATE, that change into IC, or if the name ends with ITE, change that into OUS and write the name of the acid. If you have any questions regarding naming chemical compounds, including ionic, covalent and acids, or writing formulas, please mention that in the comment section.